Okay, we're going to start on the G2 reflection, and hopefully you've watched the video that goes with it that has the notes. This is a really important page on this video. It says G1, but don't worry about that. I switched them around. It says, see, don't worry, the video says G1. The lessons were switched. So we're going to go ahead and take this problem, and I've started a cameo over here. And this is a super important picture. I'm going to go ahead and label it with the number so we can do this problem. So let me paste the problem here so I can reference it more easily. Here we go. This is problem 1, G2, reflection. All right. So a piece of clothing takes an average of 38 minutes to move through an assembly line. So that 38 right there, okay, we need to go ahead and put that down here. So we're going to put 38 here, all right? And the standard deviation is 4 minutes, and the distribution is approximately normal. Use the empirical rule. So there's a staplet, but the empirical rule is more about just using the general guidelines. So let me go ahead. I'll put my 38. It's fine there. And I can go standard deviation, so I'm going to add 4. 38 plus 4 is 42. Hopefully I won't make any errors. You'd be surprised how hard it is just adding and subtracting. I'm better at multiplying and dividing. All right, so I believe I filled that out to the right. Those should be 4 apart, 1 standard deviation apart. And then I go backwards. So 38 minus 4 is 34. I'll put that right there. And then 30. And then I believe 26. All right. So the first thing you're doing when you're doing the empirical rule is you like to have a little drawing. Now, if you ever are doing work on paper, I actually have a stamp in my classroom you can borrow, and we'll stamp it out with these marks. It won't have the areas here. So if you want to be able to refer to those, you should either have them in your notes or for your test, you should have them on your cheat sheet. So they said, what percentage of the clothes take an average of 30 to 46 minutes? So here, 30 to 46 minutes, that is 2 standard deviations away, right? That's within, so your answer, here, let me do it in a different color. And not there. There we go. Answer, 2 standard deviations from the mean, so 95%. That's it. Because you can see it kind of goes with the 95%. There's a 30 and there's a 46. So it's just making sure you understand the empirical rule. So I'll click 95% and hit submit so you can make sure I got the right answer. And look at that, a check mark. 34 to 42 minutes. Let's check that one, number 2. 34 to 42 minutes. And so that would be, looking at this, 34 to 42, that's within 1 standard deviation, right? So let me go ahead and answer 1 standard deviation for the mean. So 68%, because this is the yellow area only. So there's 34, 42, we're only in the yellow area. So that is 68%. Less than 30 minutes. So what percentage would be less than 30 minutes? So go ahead and paste that in. So less than 30 minutes, we're going to probably want to add. So that is 0.15% plus 2.35%. So that's 2.5%. So you can just add the pieces. Now, some people tend to think, some of my students have said, okay, I'm at 30. What's here right at 30? Actually, these are like thin slices. So we can only look at whole slices. So we have a slice that occurs before 26. It goes all the way to the left forever. But it's only 0.15% big. It's a very, very thin, I don't want to say a thin slice, but a very flat slice. This one has a little more height, so it's at 2.35%. This one is always at 13.5%, and then you have 34%, 34%, and it's symmetric. So there you go. If I say before 30 or less than 30, I count all the sections before 30. If I said higher than 30, I would count this green, the yellows, this green, that purple or pink, and then this last piece as well. So hopefully that clears it up. All right, let's go back to the next question. Number 4. What percentage of the clothes take more than 42 minutes to move through the assembly line? So we go back, and I'll make a note. So if we're looking at that, 42 minutes, so that would be this piece right here, right? Here, I'll do a different color so it shows up. We'll do purple because I don't have any purple up here. 42 minutes is right there, okay? More than 42 minutes. So we're just going to add those 3 sections up. So we've got this slice, the green one, which is 13.5%, plus the pinkish purplish one, plus the little edge piece. Don't forget those edge pieces. And when you add them all up, you should get 16%. So that's basically how you use the empirical rule. Let me go ahead and put the 16% here. And I think I forgot to click what was less than 30 minutes. Did I do that one? Let's go see. 2.5%. There we go. I thought we did that one. Okay. And then we'll submit our answer. And you can see we got all the points on that first question. All right, so now I'm throwing an oldie but a goodie. Trey rolls this a 10-sided die, 10-sided die 20 times, trying to roll a 5 or a 1 to match his player number. All right, so let me go ahead and then so this is the end of this piece. Now we're doing another problem, and that's this one. Okay, so the first question is, what is, and we're probably going to need a staplet, what is the expected number of times he is to roll a 5 or a 1? All right. So basically what we're going to do is we need to know, we're going to use the staplet, and I mentioned it in the reflection. I said, oh, this is the staplet you probably want. So it's a binomial distribution staplet. And so you notice there's an n and a p. So we need to figure out n and p. So let's go ahead and do that first. N is the number of times. So it equals 20. P equals probability of success, or proportion of success. So in this case, it is 2 out of 10. Why? Because, so it's 0.2. Both rolling a 5 or a 1 out of is a success out of 10 faces. All right. So there are 2 outcomes that are a success. So it's 2 out of 10. So that's 0.2. So that helps. Now it also helps to know that expected number equals n times p. So I could just go grab a calculator, 20 times 0.2, which should give me 4. All right. Now, the cool thing is, if you use a staplet and you put the 20 and the 0.2 here, it also gives you the expected value right there. It says the mean is 4. So there you go. All right, but we're going to keep using this for our other questions. So let's go back to the next question. So we're going to say 4. What is the standard deviation for the expected number of rolls? So we're going to go back to that binomial distribution. And I'm going to take a snapshot of this little piece right here. So this is a piece we want in our scratch work. So let me just grab you. So if I were to pull in the next question, okay, you can stay there. You move there. All right. So let's go get the next question, which was 6. What is the standard deviation? Well, that would be basically that 1.789. So we can just take this, and it says standard deviation right there. Oh, let me get it red. So standard deviation is this piece right there. So we're just going to go click on the 1.78. Pretty much rounds to that. What is the probability that he rolls his number 6 times? So we're going to go to the stapplet, and we're going to say exactly 6, and then hit go. And you can see there's the answer. We can just grab it, copy, and you can see it's highlighting it there. So it's showing the answer multiple ways. And I forgot to go get the problem. So calculate the probability of exactly 6. So let me go get the question. Control-C, there we go. Sorry, you're going to learn computer commands are shortcuts just because I say them aloud in my head. So this is, what is the probability he rolls his number 6 times? Make sure you say 6 times. We've already set it up because we have the N and the P. So it's 0.1091. So let me go ahead and click on that. There we go. What is the probability he rolls his numbers no more than 6 times? So we'll go ahead and put that in here. So no more than 6 times. So that means at most. So there are a couple ways you can do it. You can actually say, highlight all these. You can say the probability between 0 and 6. You can also say at most 6. Whoops, let's go to 6. And that will also give you the right answer. So both of those give you the right answer. Make sure, copy. Make sure that this highlights, whatever this is logical, all right? So if it's logical, it should work fine. And then we'll go ahead and paste that there. There you are. At most 6 times. There you go. All right. Now let's go look at the, so we're going to put in 0.9133. And then at least 6 times, we're going to go ahead and, so let's go find out what that is. At least 6 times, go there. You can have it, there is an at least, go. And there's our answer. And we'll put that back on here. Come on. There we go. So at least, okay, and then I think there's, and so it's 0.1958, so I'll make it right there. And more than 6 times. So again, just trying to make sure that you understand the less than, greater than, more than, etc. I know that can sometimes be a challenge. And looks like on this page I'm almost done with the room, so that's fine. So let's go see. More than 6 times. So that's going to be, and just say more than, go, and then grab the values right there. Copy. And put it in. And so that answer is 0.0867, so I'll make sure that I go select that on the choices here. 0.0867, and we'll submit our answer. And looks like we got everything right. We're looking good. Now we're down to the last problem, because the last problem is always telling me what you learned or what you struggled with, right? Okay, so this is where we start numbering. Given that a population is approximately normally distributed, so that basically means going back up here, right? Which of the following is incorrect? Probably leaning towards that. It says 99.7 is more than 3 standard deviations above the mean, right? Incorrect. That's fine. 68% is within 1. This one says more than, and actually this one, remember where we had 1 standard, this answer right here, we got 16%. So we had 16% was more than 1 standard deviation from the mean. So this one's correct. This one's correct. And hopefully 50% of your population is below the mean. Find Z such that 99.7% of the curve lies between negative C and C. Well, 99.7 is this pinkish line right here, and you can see you got to go 3 standard deviations. Now you might be tempted to say, well, let me pick -3. Well, they kind of define, because they're giving negative z and z, they kind of expect you to get the positive answer. So that's them. I think they probably could have just given you positive numbers here and not tried to trick you with the negatives. Okay, at a high school with 2,746 students, 686 of them failed at least one class in the previous marking period. If you have 20 students in your class, what is the probability that 10 or more of them failed? So, double checking. This feels very much like a binomial distribution problem right here. Let's see. Fail at least one class. If you have 20, what is the probability at least 10 or more of them failed? So, this one's interesting, yes. So let me go ahead and copy that problem. We're going to need to do a little work for that one. So we're going to go ahead and go here, and we're going to start. And actually, I can probably fit it in here. All right. So there are a couple things we need to know. We need to know n, and we need to know p. So it looks like n is going to be 20 students. All right. P is going to be the proportion that fails, 686 out of 2746. We're going to convert that to a decimal, so I'm just going to Google it. What was that number? 68. Here, I'll just copy this and Google it. Guess it's not going to be a pretty number. All right. So, okay, about a quarter of them. 0.2498. Okay. 686, 27, yeah, 0.2498. Pretty much 25%. But it'll work. What is the probability that 10 or more of them failed? So that means that your x is 10. Basically, we're asking probability that x is greater than or equal to 10 equals question mark is what we're trying to find. So we're going to go to a binomial distribution. All right. So we'll go binomial. We know that we have 20 and we're putting 0.2498. We're going to plot our distribution and at least 10. So go. And it looks like we are getting 0.0138. Boom. Right there. Copy. And there you are. I did that 10 or more of them failed, so that should work. I haven't looked at this question, so I'm like, did I do everything right? I hope so. 0138. There we go. That'll work. And everybody's right. So that was kind of mean of me to have that little binomial, although I don't think this is really my question. This is a book question, but it's good. It's good for you. So hopefully that was pretty self-explanatory. And again, you're always welcome to bug me with questions and share your feedback right here.